I'd like to provide an introduction to semiconductor fundamentals. So the first question is really, what is a semiconductor? It sometimes behaves like an insulator, and it sometimes behaves like a conductor. The answer is it has a really small band gap, and so by introduction of carriers, we can either get metal-like or insulator properties. Here you can see a typical band structure. We'll understand how to calculate this band structure and the implications of different types of band structures. We'll talk about something called the density of states. So this is if I'm at a particular energy, there are a certain number of states that are available for electrons and holes to fill. And so what you're looking at here is you're looking at the conduction and the valence band, and then you're looking at the density of states, which is GC or GV of E. So basically, as you go further away from the band edge, there are more and more states that are empty, as we'd expect. In order to get to numbers on carrier density, we need to multiply this by the probability of occupation, which is defined by the Fermi-Dirac distribution, as you can see here. And then we can get to the number of electrons as a function of energy and the number of holes as a function of energy. And if you integrate this, then you can come up with actual numbers for electrons and holes, which is really important in terms of predicting performance for light-emitting devices. We'll also talk about what's referred to as intrinsic and extrinsic semiconductors. So really, the magic of semiconductors is that we can essentially introduce impurities or dopants that either give electrons or holes to the semiconductors and thereby change their properties. These dopants introduce defect levels where either extra electrons or extra holes sit. Extra holes would sit next to the valence band, extra electrons would sit next to the conduction band. And so it only requires a small amount of energy to excite these up to either the conduction or the valence band. And that has a dramatic impact on being able to control the properties of these materials for light emission and detection.